All right, welcome week 4, design patterns. Okay, any questions immediately? We got a lot of material.
Yes, I have a question about the D-Link class. Is it okay if ours doesn't match yours exactly? Like, for example, it's okay?
Yeah.
Like, if it's okay if I return a node from the D-Link class?
Oh, well, you want to try to separate and honor that separation. So, you know, here's your D-Link, right? And next, previous, right? And then, you know, something you would return like a node underneath this. You know, and this might just have some values in here, you know, X or something like that. And what we're really trying to do is trying to honor this. And the reason for this is we're going to be reusing this a lot. And so if you have it kind of combined, right, it's going to actually, it's going to, so D-Link. And are we talking, maybe I'm talking about the wrong thing, but are you talking about this? Previous and X, like kind of combine it all together? Or you're saying the
we can't hear you.
I'm sorry. Is this what you're talking about, where it would have you combine the
We
two?
still can't hear unless
Still can't hear me. Oh,
no, we can hear you.
I don't know if she was talking
we
to
can't
you
hear
or-
Crystal.
Oh, okay. Sorry. Can you guys hear me now?
Yes.
I took off the headset.
Yes.
Okay.
I wonder what was going on.
So kind of like that, except Node would still be in its own class, and Node would still have the X and the name, and D-Link would have the next and the previous. So I would just have a method inside D-Link that would get a node and return the node for.
Okay. So you would have a function here then, right?
Yeah.
That would return. Now remember, a node is this. It's not the bottom class, it's the whole combo. You know that, right?
Right. Yeah, Node is still inheriting next and previous from D-Link. I got that.
You're having D-Link return this pointer?
Not at this point. Well, is it?
It is essentially. Yes, this.
I mean, in the method, there's no this inside the method. It's a static method. Well, the method that I have.
The reason why I bring this up is, how are you going to, in the future, handle 5 different objects?
So, like, are you saying different than node objects?
Yeah, you're going to have an image, a sprite, a texture, you know, a closing object.
Yeah,
right?
they're just.
How do you handle 5 of those? And so the catch here is this problem becomes stupid and trivial if we're only dealing with nodes or only dealing with one object.
I was just gonna mention, you know, the node is just the data, so you can interchange the data. That's what they're saying. Why to separate it?
Right. And so this way we can reuse. The whole idea is, you know, and this is kind of the weird feeling here we have with D-Link or we're actually with this class, is the goal is add a lot of complexity here, right? And then once we're done with that, reuse it a million times. And how we reuse it is we just, you know, derive different objects from it. Right. And so so that's kind of the gist of why we're doing this is reusability.
Okay, thank you. I see the bigger picture now.
Yeah. Which kind of gets you into what do you connect to, what do you not connect to? Your D-Link, right? So I'll say I never know where to put this. I only do a 1 monitor setup. I know a lot of people do 2 monitors, but the problem is once you get addicted to 2 monitors and you switch to a 1 monitor, you're screwed. It's the same reason why I had this really cool reverse ergonomic broken keyboard, and I would fly with this, and then all of a sudden I had to hop on somebody's computer and I'm crisscrossing my fingers and I can't type it at all anymore. So it's like one, you know, I rightly or wrongly, you have to kind of go to standardization. All right. So so here's the thing. Here's D-Link manager. So let's kind of like draw this out and make sure we kind of got our connections right. So here's D-Link. Next. Previous. Then underneath this, is something, we'll call this a node, with data. And then we have a D-link manager. Right. And now we have over here, I'll make it blue. The manager, and the manager basically connects to a manager link. Active reserve. Right. And then a node. And the idea with this kind of layout is that each colors are swappable, right? So we would put a lot of effort making our manager, complete with the active and reserve, and its contract is to talk to that base class. I'm not sure, what did I call it last week?
I think it was
List.
node base or something.
I thought it was list based.
List base. Okay, yeah, it just
Yeah, that one was list based. The
Talking about that.
D-Link base class was node based. It had like the clear in it.
right. Yeah, so this has had an additional method up here. I'll just make this purple. Node base. So the idea is that everything in blue, we put a lot of work in there. And so this is our manager. We do our finds, our search, our adds, removes, reserve, restore, and all this other stuff, right? And then we have the next layer is, how do we want our boxes arranged? This red part can be a D-link, an S-link, a tree, a hash map, a discontinuous array list, whatever.
So is that D-Link manager? It's capable of handling, or it's going to handle different types of D-Links, D-Links that have nodes and D-Links that have sprites and D-Links.
It's
that what the
generic.
D-Link
The catch here is you don't know. Think of a base class as a pickup truck, and you don't know what you're going to throw in the back of the pickup truck. You might put TVs, you might put chairs, you might put tent, you might put ostriches, right? We don't know what we're going to put inside it. So the D-Link doesn't know what's underneath it, right? We know as an architect because we know what we stored in the truck, but the D-Link itself doesn't know, right? So the D-Link can't know that. All right, so this pink area can be swapped out to different variances. And I think I released last week, and we'll go over it again. I was able to swap it to an S-Link, just as easy. And nothing else changes in our code. And then the what we're managing, node manager. Node manager just drives from manager. And I think it might even be manager base, right? I'm not sure the naming, it doesn't matter. Structurally, it's the same. And the two green things, well, they're kind of connected because you have to be able to do a create node. Well, the node manager has to know what a node is, and it has to call new, so it kind of knows how to create a node, right? This also has to be able to do a set node, right? Again, because it's a node, it is actually coupled. It's not directly pointing to it, but it's coupled because a node manager knows it's managing nodes, right? So it's aware of it, right? And so the whole idea here is that that everything in the same color can be swapped out, right? So this because we need the clear in to make this whole thing work, let's see, I think maybe the coloring might be more interesting here. This probably because we need that clear, and who's using that clear function? It's wash, right? No, it just makes
It's
this
part
little,
of the, I have it as part of the take from the list.
take
So the
from-
add, and I just call it directly instead of doing the whole wash thing.
well, the catch here is the wash thing. The reason why the wash thing is there is, let's imagine your node has 20 variables, right?
Mhm.
You need, you're essentially, the wash is a replacement to a constructor. So it's supposed to kind of reset all the fields to a ended, to a kind of a neutral state. And so that's what the wash does, right? The clear is just a function to clear out the D-link. If I remember right.
Oh, I had it set up so that the clear was the clear of the node.
Okay, yeah, and it's same
Because
thing.
I always handle the, I always have D-Link manager handle the, making sure like the next and previous are
Are clean.
null.
Yeah.
Yeah, are clean, because I just do it by default all the time, every time.
That's
I
not
never mess it up.
actually, that's for from an OO perspective, we like that. That's good, because if you think about it, every time if you are honest with yourself, every time you had a bug, it's probably an edge condition. Like, sometimes I do this, and once in a while I do this, or the end of the loop, or this conditional I switch, right? And
Or
so,
I promise that will always be set to something. I'm sure I'll reset it.
yeah.
Yeah.
So if you just sit there and say, I'm going to carpet bomb it and always clear it, whether it needs to or not, even though the next line of code might say, set it to this, right? You're like, going, why am I clearing it just for 4 lines later to overwrite it, right? The good news is, the good news is the compiler will just say, oh, wait a minute, you said X equals 0, then a little bit later you go, X equals something else. It goes, oh, screw this 0. We'll just throw that away. So the compiler will omit it, even though you did some redundant work. But it's structurally, you can't get in trouble because you always clear it, right? You always set it to a value. So we hate conditionals. We hate special cases. We like, I want to say dumb factories, right? You stand in line, you're at your station, you put 5 screws in every single door that goes past you, whether it wants 5 screws or not. You just always put 5 screws in it. And lo and behold, the bad day is when something wrong comes down that pipeline, because you're going to put 5 screws in it. All right, so this is kind of the layout, and this is why we have this separated. So we can switch out the D-Link layer. The manager layer, the blue, is we added a lot of complexity. So that's our technically our object pooling system, right? And then the last little bit is our nodes down here, whatever we're managing, if it's node, images, or whatever. So I don't know, does that help a little bit?
Yeah, that helps. Thank you. And just to clarify, create node and set node would be found in the node manager. However, they could be static methods. And so the manager base
No, not
could
static.
create nodes that way.
No, it's
Oh.
it's being delegated down to the drive object using the template pattern.
So create node and set node are in which of them?
So create node and set node, the concrete is being done here, but it's being described up on top. So we can look at
Because I'm finding it hard to do it any other way outside of your method. Like,
no, it's
every time I think of something, I'm like, oh,
you're allowed to copy my method. I'm kind of, trust me, a lot of times people freak out because I'm like going, all right, you try to do it on your own, or you sit there and you do it and you peek at mine for the sticky parts, see how I did it versus how you did it, or you totally cowboy it, do it yourself, and then when you're done, compare it, right? So those are the 3 different ways. Mimic, go on your own, but when you get to the sticky part, look at mine for influence, or completely go on your own, and then kind of, I want to say compare and grade yourself on how it is versus mine, right?
That's kind of how it is with that I'm doing, like that second way. But that's why I'm finding when I don't see things matching, I'm like, why did he do it this way? Like, why can't I do it that way?
So
But I see now that's why I'm asking. So thank you.
yeah, so let's go to this right here. So here's the manager, right? And the manager here has man base, list base. And so the manager's managing lists. There's two different lists. There's an active list and a reserve list. And the so here's kind of the whole create the node and all that other do here. So let's just chase this down through manager. We will be in add, right? So down here we'll find add. It's probably, oh, I'm sorry. So we're here and we say add. So we're going to remember when you see this, and this is a thing that we have to kind of hit home again and again until you just don't even see it otherwise. This might be the manager base. And then you might do image manager. But when you kind of, when it's constructed, it's the whole thing. So you always go from the one you're starting with all the way up until you run out of hierarchy. So if you had right, and so if you're going to create this guy here, you get this one plus this one. So these two come into the pack. So those things are stacked. If you grab this one, you're going to get all the way up to that. So you were always instantiating the manager. So we get the manager plus the base, right? Which means this is the guy we're going to be talking to. That's the thing we instantiate. That's the thing we talk to. So in here, this is going to have this manager is going to have add. You know, it's going to be in this guy right here. And so then this add, okay, what does it do? It's going to try to do some things. It's going to delegate some up to the guy up here. This guy's going to do whatever it needs to do. And then it might come back. It might come back here. It might go over to create a node, right? So you see this thing bouncing around a lot. And this is it's called the template pattern method. And basically what you're just doing is you're being very creative with responsibilities. So let's chase one through this. So add, right? So here's add. So we're at the texture manager. I mean, let's go manager add. If you want to see the code, it's pretty straightforward. Texture manager was created. We just say add bird TGA, right? We call add. So boom, we go into it, add. It goes, okay, I can't do anything. Let's go up a layer. So I call it base. So we go up to base. So now we're jumping up to right now we're in the manager class, man base. That's one here. Yeah, man base. So now we're in man base. So we went from here, now we're up into here. Add the front. Cool. So add the front. Now it says, okay, get the iterator. So we go get the iterator. Well, how do we get the iterator? We now go to iterator is a contract, right? So now how do we find this iterator? So we sit there and say get iterator, which is, I'm sorry. Where did that go? There we go. All right, get iterator. Oh, we go to the reserve. So we're gonna go to the reserve link, get iterator. So we'll go here, file down on this reserve, get iterator. This iterator is an abstract class. So then you basically, at this point here, get iterator goes down to the derived class because this is abstract, right? So now it goes boom down to here. It says, oh, hey, get iterator, great. Well, now we're in D-Link. And it goes, hey, I got a pointer to an iterator. And it goes, cool, there it is. I reset it, but here it is, it returns. So boom, boom, boom. All right, get iterator. So now it goes, okay, now I'm an iterator. So now I can use the iterator interface. I go get first and say, oh, it's null, refill the pool. So I go to refill the pool. It's a private function on the base level. So I'm here and I'm going to refill the pool in the base. There's a lot more methods here. So going down to this, I'm still in manager. Manager goes, cool, how many do I do? Oh, I need to do, say 3 of these. So it's going to sit there and loop. Well, now I have to create a new node. So now I'm at the manager. So I'm going to go back down to my drive class. So I'm in manager. And now I'm, let's see. There, create node. So this is a contract. So I'm here in private fill. Phil says, hey, loop and do create node. And in here it goes, oh, drive create node. So then it's going to jump down to the texture. And so now the texture is going to be here, adjust with, create node. Now this function is going to call new texture. So now this is going to go ... create one of these, but it doesn't create that, it creates the whole stack. So it's going to create all, this is there, but you get node plus d-link plus this. It creates all this. It comes back, create node, and it's going to return that pointer as a base link. So then it's going to return from there and go back up to the base class. It goes, cool, I got a node. It's not, I don't know that it's a texture node. I just know it's a node base. Now I'm going to add that to the front. So I go back and now add that to over here. I go to my reserve, add the front, then add the front goes down to here. Then goes front here is going to now adjust this link. Right. So you can see that we're going from here to 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 here, back here, up here, to here, to add the front, to adjust. Simple. But the thing here is, the reason why this is in this crazy town is it's for coupling. The manager base does not know at all what it's managing. The manager's base, what it knows is this. I have a couple function, create node. I don't know how to do it, so I delegate it. I push it down to my drive class. Say, drive class, you better figure out how to do it. How I do that is I do that as a contract. I call it protected, right here, abstract contract. Then this guy here, well, it has to overload that create node, cool. But it knows what it's creating because it goes, hey, I'm a texture manager. I create textures. So in this case here, it doesn't manage this. Sorry, it would manage textures. So this create node will then create a texture. Okay, well, that covers that. Well, then when I create this, I return what? I return a node base. This is agnostic. It doesn't know it's a texture. It knows it's a high class thing. I go, I know how to deal with node base. I'm going to add that node base to my reserve. My reserve, I'm going to add to the front, and I'm going to basically now correct the links here. So the manager does not know what's below it. If it needs something, it goes, hey, supporting cast, hey, somebody else, you do it for me. You do it for me. When I want to add something, I don't even add it. I hand it over to this class and say, you add it. And it goes, I'm not doing it, but I have the contract of add. Now here's the add. So the base class does not know anything below it. If it's dependent on somebody else, it just makes an abstract method to do this, right? So this kind of gets us to this this kind of idea is that if you have a base class here and you make something abstract, foo, and you derive from it, this is a contract. Your base class is your contract. This is mandatory, right? So this is mandatory. Right? And so your base class has to override foo. No choice, has to. Has to do it, right? Right. But if we did this as a contract and we say virtual foo, virtual has an implementation that's defaulted. Now, this is optional. Optional. I can overload it. Or I don't need to. This is totally optional.
And manager base has both the abstract and virtual methods
Right.
in it.
I
Okay.
believe so. I know it has abstract. Let's see.
That's what I think private fill reserved pool looks like.
So this is so here's the abstract. So these are the two that says mandatory. This is just a private method. There's nothing.
Oh,
This is a
okay.
private method. I'm seeing, do I have virtual here? I don't have default behavior on this.
Okay.
Yeah.
And can so for contracts, they can only have one or the other. They can't have both. Is that correct?
Well, if
Like
you
either
about,
abstract or virtual.
right, but if it's virtual, is really kind of both. You can put a default behavior here and it can be overwritten. You could put in here if you wanted to, and we will see this in a couple of weeks. Asserts saying, you know what, if you didn't implement it, the thing will still compile, but if you call it, it will throw an error. So it's like a trap. So virtual is optional. This is that. And remember, when we're dealing with this, when you have a virtual function here, and then we overload it, this function's only going to get A or B. It's not going to get both. So it will call this guy here, right? Or it will call this one, but it won't do both. So if you don't overload it, it's only going to call the pink. If you overload it, it's going to call the blue and not the pink, right? But here's the catch. But what if you want both of them to happen? Well, then you basically going to delegate it. You're going to go back to base.foo, and then you still can add your own stuff here. So now, now what's going to happen is this base calls and it calls the pink, then it continues and calls the blue. So that, I mean, when I was saying before with OO, all this whole class is virtual, abstract, overloading, overriding, right? And methods and inheritance. That's it. There's no more, like, we don't have that many Legos, but we have to be able to build anything. But this thing, it keeps coming again and again and again. And how most of the design patterns, what they do is they start adding the word abstract to create contracts. All right. Other questions?
I have one question about the adapter pattern we saw last week.
Yes.
I mean, the example you told about the hardware, I mean, it's just an example, right? The adapter pattern's actual thing is not for the hardware.
No,
I mean,
actually, it's for any adapting, right? Any adaptation, right?
so the hardware you explained is
be-
just an example, not the purpose of the adapter pattern.
No, you can, the adapter pattern is to adapt A to B. That's it. You can have this. You're in England and there's those really honking plugs. I don't know if you've been to England. I think there's some, they look like this, right? And then you're in the United States and it's this AC plug to that AC plug, right? That converter is an adapter, right? That converter is an adapter, right? But adapters could just be, it could be the same size plug to the same plug, right? You can be the same thing. It can be an A to an A, but what you're going to put in here is a fuse, right? So if you want one point where everything chokes through there, that's adapting A to an A, right? You're still adapting. So an adapter pattern, don't get too hung up on the word. And first of all, the word they're using is wrong. Right? It should really be adaptor, right? This means mechanical device or machine. This means a person. So stupid computer scientists don't know the definition of the words. So in literature, it's called adapter, but technically it's adapter with an OR, right? Little side note there.
Is that why they call it an iterator instead of iterator?
No, actually iterator, I'm sorry, adapter with ER and OR are two different things. One is a person, the other one is a device or a mechanical connection, right? So now iterator doesn't have that. One who iterates is an iterator, right? But the concept of iteration is an iterator. So that one's actually okay, at least in my opinion. It doesn't change. It's just, you just look it up.
Just to confirm, PA2 hasn't been out yet, right?
Okay, yeah. So here's, let's talk about sprints and PA2. All right, so this quarter or this year, this class, I'm adding PAs to enhance everybody, right? Problem is these PAs are kicking my butt writing something as precise for you guys, because if I sit there and just say, write this pattern, and I don't check every single line and every single link and every single type, right? Then essentially it's a sprint, because sprint, you have the freedom to kind of do it your own way a little bit. You can take the pattern and mutate it a little bit. You can return things in the wrong order, but it will still work, right? So I was trying to make this PAs being very, very, very precise. And you saw that with PA1 as very precise. Well, tonight I'm releasing PA2. Right here. Here's PA2. And PA2 has adapters, singletons, iterators, and factory. And here, so here's the iterator test, and it just keeps going. Here's the singleton test. Here's the adapter test, and here's the flags to adjust and set these. So it's taken me a lot to A, come up with the problem, and B, come up with the test. And but that's okay, because here's how I'm seeing things is that every week, we have the sprint, and this is your game code, right? And there was some confusion there, and I'm sorry if it wasn't as clear there. What you're going to do is every week it'll be sprint 1, sprint 2, sprint 3, sprint 4, and you're going to do full. This is your game, and it's just going to get bigger and better and more complete as we go. So the first week was just, like start, and you put the whole Space Invaders in that project. next week here, this is where we're adding images, texture, sprites, and managers, right? Then this one here, we're adding sprites, batches, and animation, animated sprites, and timer. Then this one here, we're adding composite pattern, so the collection, and it just keeps going. So every week the game gets more and more complete. And so this is going to be released every single week. And then depending on where we are in the class, I'm taking the comments, the problems, and stuff that people are getting hung up on, and I'm writing the PA for that. So sadly, this takes me multiple days to write these things. So when I release Sprint 3, I'm going to release PA2. This just be delayed 1 week, and then when it will take me a week to write PA3, and then 4. So this PA2, 3, PA1 is essentially reinforcing the stuff you used in your sprint, reinforcing the concepts, right? So they're going to be off a week, and no matter how I do it, I can't pull it in. Last year we didn't have any of this stuff. This year is all new, and I think it's really useful because it's being pretty thorough. So the question I have for you guys: did PA1 help you in your understanding? Did it catch you and it's like, holy crap, I can't do this? So maybe I tripped across a weak spot in your coding ability at this moment. Is it useful?
Yes.
I thought
Yeah,
it was
it's
useful.
good actually.
I just thought that like they were gonna come out at the same time. So
Well-
because I found PA1 useful, I'm like, oh, PA2 will be useful for Sprint 2 because I didn't do the D-Link for PA1. I'm like, we're gonna do it in Sprint 2. I mean, yeah, week 2. Like, I don't have to do it now. And then of course PA2 got delayed. And so I'm like, oh, well, now I have to implement D-Link. And that's why I kind of got like, I know how to do it, but I was thinking of the hot dog order stand that we did for C++.
Yeah,
And I'm like, why can't I, use Node?
no. So
Well-
here's the reason why. It's kind of like this. I do this in my optimization course as well. I give everybody the pointer test, right? Well, you guys should know how to do pointers. You know how to do this stuff. We talked about it before. And then also when you kind of fumble with the pointers, then suddenly my lecture makes more sense, right? So we're talking about these design patterns. I'm actually showing you code. I'm demonstrating the pattern, right? So like if you need a reference, there's the PowerPoint. There's you Google and look at the reference material. So designs, do factory, just Google the pattern. You'll find a lot of linkage about that stuff, or head first patterns and other books. And you start using it. And then the PA is kind of like, okay, well here we're gonna like test your ability. Do you really understand it? Are you really using it correctly? Trying to push some minutia, right? So like, so I'll give you an example. So this one has the one that's going to be released tonight has iterator, right? Right. And the methods are going to be, first, next is done, and current, because you can read the node multiple times without indexing through the machine. All right, so here's your linked list. Let's say, well, this is pretty straightforward. So linked list, and here's the head. All right, so the first points to this one, right? Then the next will point, next, and then you can kind of get to the end. And when you're here and you acquire the last next, the done flag is set, right? And if you call next again, you're going to keep returning null. Well, I have you do a linked list that way. Then I also said there, okay, I want you to do a linked list, go in reverse order. So this is your first node, and I want you to go that way until you're done. Then I'm going to give you, so, you know, like Amazon has trucks. You can tell I'm sitting at home and I got a delivery. Trucks. And it has packages. So it has a box 0, 1, 2, 3 in there. Let's just say the trucks are small. But there's multiple trucks. So the trucks are linked together. And then each one has boxes. Right? And so now you're gonna make an iterator to iterate through the boxes. So you're like, okay, well, give me this box first, and this box, and this box, and this box. Oh, I'm at the end, go to the next box, right? But that's too easy. So I'm gonna sit there and say, this was delivered, that was delivered, that was delivered, that was delivered. Now iterate through the boxes. So the first one will give you this one, the next one gives you this one, the next one skips 2, goes to this one, the next one goes to this. And so you'll get all this, and you have to figure out how to iterate through this and return the iterator correctly. And it's showing you that an iterator can walk through non-array data. It can walk through trees, it can walk through anything. And this kind of gives you an idea of how to do the abstraction. For the singleton, if you go by the classic singleton, ones you read in the book, it has a static public method. We'll get, oops. Get instance. Then we have methods here. You know, we have public methods. Foo1, Foo2, and so forth, right? Well, that's it. You have to, there's no other way to construct the class. The first function has to be called get instance. You get a handle back to the class, and then you can go .foo1, this, and start using it that way, right? That's one style of singleton. The way we're doing it in the managers is we're burying it. So now static method, you know, add, void, remove, you know, void, you know, create, you know, all these static methods. Well, on this class, you don't see the instance at all. The instance is inside of this as a private, you know, class get instance, and you do lazy instantiation here. If the pointer is null, then you call new on the class and you return that pointer. So this is inside of here, and then inside of each one of these, they call this guy, and you never see the singleton externally, the instances externally. And this is right from the lecture stuff that we did. So I'm trying to really shake out the PAs to get down to the mechanics of all the problems we're doing. But you need to kind of start plowing through and working on this stuff from the normal lecture material. If that makes sense.
Is Sprint 2 still due this Saturday then?
We'll make it Sunday. I'm behind on grading, so Saturday, Sunday is not going to matter to me.
Okay, and then we'll be getting back like our sprints and PAs, so we kind of know how we're doing on these.
Well,
things.
the PAs, you know what grade you got is what you got.
Yeah.
Right, so that shouldn't be a surprise to you. And the sprints, it's just, I'm not think when I got 50 students, I'm not going to spend 7 hours per student looking at every line of code doing. I'm doing a quick video. I'm going to spot check a couple areas of code and kind of give you, you're on the right path or you're behind.
Okay, thank you.
And then we're going to have a milestone that I'm going to go deeper into your code and make sure everything's hit on the milestone. Okay. Does that,
Oh, I was
that
just, I have a
clarify?
question about, yeah. So I was just gonna say, so that's really how it's gonna be every week. You just have the sprint. It's just, it's always gonna be due like on the weekend.
Right. Yes.
All right, gotcha.
Yeah. And I'm going to try to get the sprint out tonight. So you'll have the, you know, basically a week in a couple days per sprint.
Right, so it's always, you always like give a week. So when you posted it now, so that really should be about a week then,
Well, you know,
when you posted it.
it's going to be, no, it's going to be, everything's going to be due on Saturday. We're right now
Okay.
a little bit out of sync. So give it another
Okay.
week. Give it another week, it'll be on there. So this sprint here will be on Sunday. The next sprint will be on Saturday. We'll be back on track.
Okay, I understand.
The PAs are going to be also, you know, a week lagging too. So, you know, it'll be when sprint 2 is due, PA 1 is due. When sprint 3 is due, PA 2 is due. So this way, you know, you're following it up and shaking that out as well.
So like you said, it's just gonna be, you do a sprint and then you can kind of check with the PA the next week.
And the PA is just to either reinforce that you know it or clarify issues you don't know. It doesn't mean you have to immediately run back and fix your sprint, but moving forward, you should do it better. If that makes sense.
That's like the structure that you want to generally follow. You want to be able to pass those tests, but you can still do it otherwise.
Right. Because the whole purpose of the class is that you understand how to use the design patterns in real structured code.
Right.
And this is where, you know, sadly, the first thing we start off with is the manager, which is quite complicated.
Yeah, it actually reminds me of what we're doing in optimized right now. Like it's very similar.
No, not even close. But anyway,
well, I mean like
that.
the double linked list kind of deal. Like you have 2 linked lists.
But so what's happening now is that what we're going to do is start cleaning up our code. So at this point now, from last week, so last week we had we started adding images and textures, right? So image and textures. So image and textures. Image and textures. So here's kind of the code, the original code, right? Create a texture, create a sprite, update the sprite, and then render it, right? So this is a Azul texture, Azul sprite. We're going to wrap that with our own. Why are we going to wrap it with our own? We're going to extend it. We're going to add more data to it. We're also going to buffer it from the hardware. So we're basically going to wrap it. So we won't talk directly to Azul texture. We'll talk to our own class called texture. We'll have additional fields, and then we'll marshal that data over to the Azul texture through the adapter pattern. So if you look at the original stuff, we have Azul.sprite and we have the texture. So it passes the texture. The next thing it's going to do is pass the sub rectangle in the texture. So see that little sub rectangle in the texture, the blue. Then the last one is the starting rectangle on the screen. So here's the starting rectangle on the screen. So center, here's the width and height, and that's the green, right? And then we update the sprites X, Y, Z, X, Y, this rotation and scale, and we call update. The update is to push it through to the hardware. And that update would be going through our abstraction. And then we're going to call render, and it will draw it, right? So that's the concept on the high level. So then what we did is we kind of created these classes a little deeper. So Azul, the Azul texture, what we're going to do is create our own texture, and we're just going to add the word name, and it will point to the Azul texture. So what we're doing is we're adding the word a name to it. We're not going to derive from it. We're just going to actually have it as an aggregation. We're going to literally point to it. So technically speaking, this is you know, a connection, right? And then the image will point to the texture. So this is a open triangle. So the texture points to the texture. That's all its job to do, is point to this little texture and have a name to it. The image has a pointer to the texture, and it also has the sub rectangle right here, this little rectangle, right? And that's it. So now let's look at the sprite. So I can arrow down. So sprite. So a sprite is, you know, what's on the screen. That's what we see. We have a center point on the sprite. We have a height and width. And so what we do as a sprite is the sprite points to a texture. I mean, the sprite points to an image, which is a sub rectangle on a texture. It has its local, you know, X, Y, SX, X, Y, an angle. And then it points to the actually Azul sprite. Right. So here we go. So here's the class. So a sprite connects to one sprite, you know, one of our sprites equal one of their sprites. So it's a one-to-one relationship, right? All right, so a sprite points to the Azul sprite. It also points to an image. This image is our image. It has a name. The image then points to a texture, our texture, and that texture has a name added to it. And now it points to the hardware texture. Right. The image has a name. It's going to point to the rectangle. So this rectangle is used in this texture. It's used in that texture to define that little clip out region. And then that little clip out region and the texture is what we're going to use to push to the sprite. Right. So we're using the adapter pattern to wrap these two. So now we can change this by just adding our primitives in there. Our code gets a lot cleaner, in my opinion, is that now our texture, instead of using Azul texture, we just say, hey, texture, we give it a name. So we're adding a name to it. We can call it anything, monkey brains. It doesn't matter what we call it, but we add a name. And then there's the original argument of the texture. That creates our texture. We'll call it the Paul's texture, right? Then we're going to create an image, and we're going to give the image a name. Then every image points to a texture. All right, well, there's the texture. You can see here, here's the textures. Always highlight with a black marker. Image texture, right? And then what's the subregion? Well, here's the subregion, right? Subregion. Now we're going to draw a sprite. The sprite needs an image and where you want it on the screen. So our image, it's right here. So the first thing we do is image. We give it a name. And then here's the location on the screen. So when we call update, the update is a push because it's going from our wrapper to the hardware. And then the draw becomes a delegation to the wrapper as well. Right. So the idea here is then eventually we can now get our managers. Oops. Right. So here's our manager. So every manager will become a singleton. So we can say texture manager, no matter what file we're in, where we are in the code, we go texture manager dot add, texture manager dot bind, texture manager dot remove, right? So we can add and remove textures all day. Same with images, same with sprites. But then the images, right? The images point to other items. So let's say here, this sprite right here points to this image, which then points to this texture. And you can see now the ownership issue is that all the objects are owned by the manager. So anytime I can call freeze and I can say every single object in the game, who owns it? Who has the black diamond? There's only one black diamond on any device at any one time. So everybody has a black diamond. All the textures are owned by the texture manager. All the images are owned by the image manager. All the sprites are owned by the sprite manager. But that doesn't mean we can't point to the sprites, right? So, so now we take the pink one, starting the sprite at the bottom. The pink points to the image, which the image points to a texture. Okay. But now let's kind of follow this backwards here. Let's sit there and say, let's say we have this image here in green. We can have many sprites. Sprite A, sprite B, and sprite C can all point to the same image. So now we're reusing it. And that image points to, you know, that texture. And we could likewise have another image point to that texture. So now suddenly, by having this manager, we know who owns it, but we can have multiple objects point to the same object. And that's okay, because it's effectively at that point kind of static behavior. It's read only. We're not really modifying it. And so what we're going to get is this relationship where sprites point to images, images point to textures. We can have many sprites point to the same image. We can have many images point to the same texture. So now we get reusing of the data assets naturally out of our architecture. And how do we do this? Is that our texture manager reuses the manager base. Our texture, reuses the whole base. And then what we do here is we have to overload the add, remove, and find, the dump and wash, because texture might have 20 variables, or might have 2 variables. So we have to make sure we wash it correctly. The dump is just a print. Same thing, image manager, we would just derive from it. Image manager would do this, and suddenly everything above that line is reused.
What is, there was like the sprite box or whatever?
Yeah.
Is that just a way to draw a box on the screen?
Right. So out of the
Okay.
primitives, if you go back to the original Space Invaders, one of the primitives was so in the original Space Invaders, one of the primitives is a box. And why do we need this box? It's a special, it's actually drawn by 4 lines to form a box. And the reason for this box, and we can change the colors, is that we're going to start using this for collisions and do that stuff. And the weird thing here is, and I don't know if I've described this at all, but what are 2D games? 2D games are just boxes, colliding with boxes. As it moves up, it hits, that's it. And then what we do is we paint pretty pictures on top of it to make you keep interest in it. But what we're really doing is this boxes moving, boxes colliding with boxes. And so when we're in debug mode, we might want to switch in there and say, okay, let's say we have a an alien. Right, so we have an alien, and then all of a sudden the missile comes up, and it's like, and you have really good eyesight, right? So this missile comes up, and you're like, going, hey, it just said it collided, but clearly it didn't collide. Look, it didn't hit anything red. You're like going, well, let's look at the bounding box. Actually, it did. The 2 boxes intersected. That's why you got a collision, not because of the graphical artifacts, but because the boxes collided. So sometimes we have to switch between boxes and images to see what's going on and why it's going on. So in the original code, there's boxes. And so just because we just figured out how to do sprites in images, and that's the sprint, I believe, right? The sprint is to kind of start adding the labels and the logic. Now, if you haven't had my class before, for architectural courses, I do a lot of little drops, and you have to kind of diff between the different drops to understand a lot of things. I'm going to highlight the big ticket items, but I would need an 8-hour course lecture to talk about every line of code and every little minutia. And the reason I do this is I quickly try to go through a lot of this stuff. You'll follow along. You have the reference material at home. You can start differing this, and if you don't understand stuff, you can also ask questions on Piazza. It's a way to kind of get higher transfer of architectural knowledge to you. So last week, we went through all, we added the image managers, and we ran out of time a little bit, but we added image manager, all those different managers. This is on. So now our game now has sprites. We look at our diagram, and here's a sprite. And a sprite points to, and this is why this tool is kind of cool. Get comfortable with this, where you just sit there and go right click, add new, and you'll say class diagram, right? And boom, and you get a class diagram. And now you can just go in here and go, okay, just drag the sprite over to it. Open it up. You go, oh, here's a type, shows the association, boom. It goes to an image, boom, right? Open the image. Hey, look, there's texture, boom. You know, and then depending on how crazy you want to go, well, this texture goes to a base link, and you can see that these two are linked together. You know, I mean, this, they're not connected, but remember the whole hierarchy that we talked about earlier, is that image, when we instantiate an image, you get image plus D-link, or if you instantiate texture, you get texture plus D-link, but there's still a base class above this. So image, node base. So boom, boom, boom. All three of these things are stacked together when you instantiate image, or all three of these things are stacked together there. So now we're starting to kind of abstract this, and the code here in kind of the scorecard I always look at is, what does this code look like versus the original, right? Well, here's the original. First of all, let's look at the original. Here's the original. So here's the original. When we oops. This one. One second, let me close. I'm already got myself confused. Okay, so me too. All right, so here's our start, right? Here's our starting point. And let's look at how do we create a sprite, right? So before I break, I have a habit of breaking my own code. So copy. All right, so here we go. So so here's our start, right? And what we want to do is look at this thing and say, okay, what does it take to just draw a triangle on, a sprite on the screen? And we look at this and go to main. There's not much there. Here's the game. And it's like, okay, we have to load up a texture. So we'll load up an alien, right? Yeah, we'll do an angry bird. Load up a bird, right? And now let's so here's a bird texture, right? And then so we load up a bird and load up a texture, and we create a sprite using that texture. Now we define the subregion of the texture and then the subregion on the screen. And this is a yellow bird, of course. So then we want to update it. Yellow bird. What I'm trying to do is give you a demo that had everything in it. So this way you kind of see. And so here's our yellow bird, and our yellow bird's going to move. And right, so here's our yellow bird moving, and all we're doing here is glorified increment the x, increment the y, and then when it hits the edge of the boundary, flip the direction. Right, so we have load a texture, load a sprite. And now here's the full thing. We have to take the pointer to it. We have to take the subregion. We have to do a subregion on the screen. Then we move it around on the screen. Here, let's see. We can make this simpler. Move around the screen. It's going to start. We're just going to add one to it. Right, and then we're going to draw this. Draw the yellow bird. Right. So this is kind of gets to the base thing, right? We just got one bird. It's going to bitch at me because I have a ton of temporaries, right? See, okay, so it's moving. All right, so let's look at that one again. Now, what we're going to have is on later drops, right? We're going to have, here's a sprite. And now our later drop's going to look like this. Right, so we have, sprite goes to image, goes to texture in this, right? And what we'll get on this, again, I'm going to take a chainsaw at it. Let's keep a bird, keep the yellow bird. We want a yellow sprite. Do some wrong. Delete. There you go. Shit. Delete the lines, right? All right, and then update yellow bird. Yellow bird is 1. Right, so here's our new code, and my hand's right on it. All right, so here's the new code. We're creating a texture, but we're also going to add the name to it, right? Then we're going to sit there and say, okay, create an image. That's now that subregion, right? So the image is the subregion in the texture, this blue box right here. The blue box in there, that's the subregion, so that's the image. And so it's going to use this texture. So this texture is called birds. We're just going to, here's the pointer to it. The image name itself, we're going to call the image a yellow bird because that's the yellow bird out of it. And then here's the subregion rectangle. Cool. And then what we're going to do is now for a sprite, well, sprite needs to point. So here's a sprite's name, and it's going to point to this image, which then this image points to this texture. So just by putting that one link, we get all that crap. And now it's only the part we're worried about is the location on the screen. But because now we have a texture, image, and a sprite, now we can see here, it actually is going to push to a real sprite. It's going to push to a real texture. So now when we update it, we're updating our abstraction, not the hardware, but ours. So we go to update. And here is the push, right? This is the push. We're going to copy our X, Y, Z and angle to the hardware sprite. So we're going to push it all there, then call update. And this is critical. So what's nice about this is that I can do this 100 times, right? And it doesn't update the final sprite until I call update. Now, this looks silly right here, but imagine you had functions, it goes to functions, which going to iterators, which is going to collision objects, which moving this, which is reacting this. And so this poor little object's getting bounced around, changes directions, changes size, changes shape, moved around on the screen multiple times. And and the answer is, okay, now update it. So at first it seemed like, wow, why don't we just update every single time? But no, you keep it on in your cache before you write it to the hardware. Okay. Now for the draw, we're going to delegate it. So we go here. And in delegation, it just says, you do it on my behalf. So I'm in the sprite class. In the sprite class, I go, okay, render. We'll just push it right through to the hardware render, this little sprite render. And so now our code's a lot cleaner. This still looks the same, but actually it's behaving slightly different underneath the hood. So it looks the same externally. And then this starts dealing with abstractions. Right? So now we're like going, okay, cool. But once I want to create, 50 images and 50 sprites and 5 textures, I'm going to have a lot of local variables to keep track of that. That's cumbersome. I don't want to keep track of 50 variables. If you think about it, Space Invaders, there's 55 aliens, right? So there's a lot to keep track. I'm not going to keep track of 55 names. That'd be ridiculous, right? So so now week 3. And you have to look at this code. It's not going to, you're not going to figure this out, stationary. All right, so here's where we were. We just added the abstractions. So oops, that's the original. That's right. Oh, it's right. Here we go. All right. So just finish with one minute. Finish. 2.772. Right. So now what I need to do is start to clean up do some cleanup, and there's some housekeeping. So if we take these two and diff them, you can see what I did differently. And now what I did is I integrated the manager that we've been working on. There's all the manager. Added that. And now I just did a little bit of cleanup here and moved it down and reduced the problem. So this right here is, this code here is, before you do something, is first thing you do is integrate it into the library. I think I just included this twice. So you integrate it into the system. Oops. Get rid of all of it. Right. No, fire that. And now we can start to add the managers. So before you use something, you integrate it, make sure it compiles. You played around with your test bed. So here's all the managers. And here's my design class layout. And what I did here is just to show you, remember how we had before in our class, we had, you can swap out the red here, the D-link. Well, I actually do that, and I call it a single link list, right here. So I prove that idea out by saying, all right, list base has either a D-link or it has an S-link. So I just tried that idea out. So here it is, no manager, boom, 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 right? Then I tried the S-link manager. And the S node manager, which is a single link list, or the node manager, which is a double link list. So I tried both of those out. You can see here's the two diagrams, kind of hairy, but essentially, if I delete this, right? So I have S manager and right. So I just basically replaced that layer. And now this should all run as an S nodes. I'm managing S nodes, and I replaced it with the S link manager. And so this was just the shakeout to prove that out. And won't see anything here because it's all on output here. And we can see that I have my single link list, and I can print it out like we had before. Then we also have the double link list. So I'm just showing you that if my abstraction was right, I should be able to swap it out. I can make this a hash map, and that should work, right? Right. So now the next drop is add the manager with the sprites and images and textures. Right, so now I have this. I have the class diagram, right? And so we go into the image, the texture manager. Here's my texture manager. Let me quickly put a diagram so we can see this. And I find that the diagrams are it's even easier than drawing it. Texture. So here's my texture diagram, and I haven't integrated anything yet, so that's still, I think they're all separate, right? We're not there yet. All right, so all I did is I put these things back in there, make sure this is all cool. So I'm just proving it out. So here's my texture. So this is like the last other demo before that. All right, so the next one is I made those managers. Now, the stuff I'm showing you, it takes me 2-3 minutes to show you this. It's taken time to code it, to understand it, to do it. So, you don't get this free. You have to kind of earn your way through this. So now I have here is I basically create a texture manager and image manager. So here's my diagrams. So here's my image manager. We'll do texture first. Texture manager, manager base, drive from it, texture manager, list, blah, blah, blah. Then texture. So here I'm just adding these two guys, and then I fill in the appropriate methods. So here's add, right? And now this is where I do my casting. Then you'll see down here, you'll see derive created node. There's my new texture. Here's my comparison for the comparison. right? And I do the same thing for the image. So image manager, which I back cut and paste. Image manager. There it is. And so here's my image manager and my image, and I reuse the rest of the mess. And I just fix this class and fix that class. I'm done with that. So now here's where the win is. Now when I start my game up, I say create a texture manager, create an image manager, bing, bing. All right, texture manager dot add, we're gonna call it birds, or add Pac-Man. So I'm doing this as enumeration, so we don't have to deal with strings because strings are slow. We need the string for the loading to a hard drive. This is the only time you'll see a string in the whole game. But right now, this is your enum. And so where do I have these enums? In texture, you know, they're just placeholders for now. Enum, so I just give myself names. If I want a new name, I just turn around and add a new name to it. You know, right? So I can add names as I want, mix caps, however you want to do it. It's just an enumeration. So now I create the images. And what I'm doing with this is I'm cookie cuttering all the things off of this sheet. So we look at this in resources, birds. There's a bird, so I cookie cutter a red, cookie cutter a yellow, a green, a blue, and that is called images. So here's the images. Red uses the bird texture, and here's the bird subrectangle. Yellow uses the yellow thing. Here's the subrectangle. Green, white, and so forth. So those are my images. Now I can reuse these images 100 times. And do the same for Pac-Man. Okay, so now I create a sprite. So I want a sprite. I'll call it red bird. I point to the red bird image, convenient name, and then here's the location on the screen. The same with the yellow, green, and white. And now, because these point to the image, I don't have to pass all that data about it's encapsulated. And I put those guys on the screen. And what's nice now is I can actually print out my manager, because my manager has printing capability. Right, so here we go. Boom. And now this is all my textures. And in textures here, it says, okay, I currently have 2. And the first one's called birds, and the next one's called Pac-Man. I'm sorry, first one's called Pac-Man, the next one's called birds. Then I can sit there and, okay, my images, boom, here it is. Here's my images. I have 8. It's called orange ghost, blue ghost, pink ghost, red ghost. And then it goes into birds, white bird, green bird, yellow bird. So there's my images. So you can see how the manager is starting to work for us. Now I can sit there and move these things, update them, same as before. And then I can call render and render those.
Should our game.cs match yours
No,
along the way? No.
no, it's going to start varying very quickly. So here is this, you know, there's the 4 things, right? But what's nice about this is that if I wanted, see how I have all these, the ghosts. So it's, you know, red, pink, whatever. If I make them, if I just change them all to point to the same image, they can all be the same. So I can go into this, and this is where, because you know, there's just, I'm just changing the pointers. I can sit there and say everybody points to the red one. Now I have 4 of them, but they're all pointing to the same. so that's an interesting thing. I can kind of move and change that. All right, so let me keep going. All right, so now I'm going to sit there and do this for a sprite. So now I'm going to add sprite in the sprite manager. The reason I'm doing a sprite in the sprite manager is obviously I don't want to control 7,000 sprites when I have those in the manager, but I also want the manager to do something for me. So if you notice in the previous thing, we had a call blah, 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 update sprite, blah, 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 update sprite, right? And what I could do is just cut and paste and put all the updates together, right? Then I have to sit there and go all the renders together, right? Well, what I could do is just create a manager for this stuff. So now my game, I created a sprite manager, same pattern as before, drive a sprite, and the sprite manager, everything else is the same. But here's what's different about this is that now now I sit there and say sprite manager add, sprite manager add, sprite manager add, right? And now I can, oh, this is my first step, right? So I just get this thing working. Don't bite too big of a step off at a time. So now I'm just having sprite managers. Nothing looks really different. But the next step is I want to sit there and I noticed when I looked at this code, I'm like going, well, this is this commentary. I'm calling new. Why do I have to call new every time and then use it? And I have to call new manager and then use it. What if I make this a singleton? What if I make the texture manager a singleton, an image manager a singleton, sprite manager a singleton? That would be kind of nice. And so my next drop is, yes, singleton. And so this is the singleton. And so singleton is just a way so you don't have to, there's only one copy. You don't have to do it all the time. So here's my singleton. So when I call image, I'm actually going to have 3 or 4 functions on image. And the functions on our image manager are going to be image create, destroy, add, find, So basically what I'm doing is saying all my functions are going to be static functions. And so the pattern that I like with this one is that, you have the image manager, and you have a static function create. And then what's the complement to this? Destroy. And this tells you your reserve. So you sit there and say, I want 5 and repeat 2, right? Or you can leave it default. The destroy is when you leave the function, it destroys it, right? This is where we can do our homework or our cleanup. So when we leave stuff, we can put in here and we can sit there and say image manager dot destroy. And now what we can put there is, what was our total number of images? What was our peak? What current number do we have? And we can tweak our numbers then. Then we can go back to our original and say, you know what, when we created this, it creates with a 3, 3,1. But I noticed when my game ended, I had 9 of these. So when I just reserve 9 up front, boom, now there's no news in the game. They're created at this moment in time. So I have a create and destroy, and then everything we do normally, add and remove. So I have add, remove, find. Now, normally when you call these functions, you would have to normally go like this. You have to go image manager, P equals new, image manager, right? And you go P add, P, remove, P, find. So this is how we've been doing it to this point. But now that means I have to pass this pointer to every class, to every function, to, to wherever I need to, whenever I want to access that manager, I have to pass that pointer around with it. And it starts becoming heavy, right? So what I want to do is this, it's saying, you know what, I'll make it all static. So I go image manager dot create. And I'll say, okay, create 4 of these and repeat 2, right? Then I go image manager dot add. And then, boom, boom, right? Then somewhere else in the code, I can go remove, right? And what's nice about this approach is I can be in some little function here and I can just have global access to it. And I can go image manager dot remove, and boom, I'm doing this, and I don't have to pass in a function. And the way we do this is through a singleton. So last week we talked about singletons really briefly, but the singleton here is just basically a globalized way to get to the data. So it's just basically an instance getting the data. If we look at a singleton, oh, design is a good reference. Here's the pattern, and it just basically says get instance, returns the instance, and you can do this, right? And here's like pseudocode, get the instance. If it's null, create the instance one time and return it. In subsequent accessing of this function, you skip the creation. This gets skipped, and you only return the pointer. And this works because the instance is a static pointer, right? Well, that's cool, but it's a little bit cumbersome, and I don't like this style. So that means you do this. Whenever you want to use instance, you go image manager, you go P image manager dot get instance, right? And now, so yeah, now you go P add. Well, boom, you can do this, right? So it's behaving like an instance all over the place. And all you did is you just had somebody go inside the cookie jar and hand you the keys to the car, right? They just went in the room and hand you the keys to the car, and now you use the keys to do anything to the car, right? The problem with this is this doesn't encapsulate it enough. You shouldn't even know that there's an instance or how the pointer works. Let's pretend that this function costs cycles, right? It costs cycles, right? A lot of people will do this. Image manager dot get instance dot add dot, and they would repeat the same line 100 times, and it will work great. And from a classic CS standpoint, you pat yourself on the back saying, yes, it works. Not from a performance standpoint, because by calling this get instance, you're doing unnecessary work. So the problem here is now you have to, it gets it in here. Well, you're using it 5 times in a row. And, you should probably just cache the one pointer and then use the pointer 5 times, but you can also call it this way, and there's no preference. And what you're really doing is giving a pointer to the things. What if there's a method in there you don't want the customer to use, and it was public, they can get access to it. So the approach, by making it static add, the color just does this image manager, and you underneath the hood bury the getting of the instance pointer. You hide all that stuff. You can cache this stuff. You can do anything you want with that. And so inside of this function here, this is where you can essentially you can do your get instance in here, but you can make this a private function. And now you can get access to the variables inside of here, right? And this is all hidden to the customer. They don't see that. Once you get the pointer to this, then you can call subcalls. You can call the subtract. You can call the find, without going through the instance grab again. So you have a lot more flexibility and you encapsulate this. And there's no way somebody gets the keys to the car and they can do stuff with it. So this instance here, so we do the image, right? So the image one is what I switched. And the image goes through here and says image.add. Let's see what's happening here. Image.add. First thing it does, it says, go get the private instance. So it goes, boom. And it goes, okay, this thing better be a real value. Cool, it is. Well, what I did here is I just returned the pointer to it. And now I go back to the add. And now I get access to it, then I can do all my rest of my stuff that I normally do. The reason why I can do this is that I know this pointer is valid. Why is this pointer valid? Because I created a front door. I created I created the create. You have to do a create once. And when you do the create once, that's where I allocate the data. So now when I do this, let's go back here to the game. Image create. When I create this, this is where I do my one new. Then forevermore, I never call new again or even check that again because it's valid because there's only one time you do this. If you happen to call create twice, I can catch it with an insert because it should be null when you enter in this and it should be called once. So then I get a handle to the instance, and how we do the instance is just a static pointer. And then when that stuff comes back, we it's initialized. So therefore, from that point out, add, I just call private get instance, which gives me that. Find, I go private get instance. Remove, I go private get instance. And private get instance really just returns the pointer. And we have an extra safety here to make sure it is not null. Right. So what that means in the game is that we do image manager. I don't have to keep around an image manager pointer anywhere in the game. I can be in any file anywhere. If I want to be in my input, down in the bowels of my input function here, and I want to go image, manager dot add, I can do it. I don't need to have that pointer with me. So that avoids me from expanding my argument list to pass in this stuff all over the place. So it behaves like a global access. And now I can just go image manager.add, image manager.add, right? Or remove. Right. So that kind of sets the tone for the singleton, right? Now let's go further. So now we're going to add for the sprites and the textures. And stop me if you're not following this. All right, so of course the game's gonna look the same. but structurally we're starting to clean this stuff up a lot more. And so now it goes create, and it says texture manager dot add, image manager dot add, sprite manager dot add, right? Okay, so now we kind of got this going, but we look at this and we're going, well, we got all this stuff in our sprite manager, but we have to call update all the time. And that's the next problem. So why don't we, oh, the other thing is the news, right? When I pass in, you know, every time you do a new, this is calling a new, which is super slow, right? And it's going to go into the add. Then it's going to go to that variable right there. And it's going to basically pass this variable to the set. The set's going to go into this. And then here's the square, the rectangle is being passed here, and the data is getting sent there. So I'm essentially constantly creating new, and I'm setting that out, but I'm going to reuse it. So is there a way to speed this up? So this new seems a little bit redundant on the sprites, but we have the same thing on the image. The image has this new here. And again, if we go into image add, here's the rectangle. It goes into the set. And the set goes, okay, here's the rectangle. And then we're going to copy it over, right? So can we get rid of these news? We always want to try to reduce as many news, because every time you see a new, it's basically adding more weight to your car that's going down the street. It slows it down, right? So how do we get rid of that? Well, first thing we're going to do is we're going to pass in to our game the variables directly. So here's the rectangle coordinates directly. Image, you know, 1, 2, 3, right? But we still need that stupid image thing, right? The pointer for that container. So they come in raw, right? We update our set, so now it takes in those variables raw. And then we're going to pass it into this rectangle. And so this rectangle here, we're just going to take the rectangle that was there. Instead of doing an assignment, we're just going to set the parameters directly. So what was happening before, there was internally, there was the, you know, the image. So PO rectangle image, oops, dot equals input rectangle. And so what this is happening, this is the assignment operator, right? So we sign it, so it takes the X, Y, width, and height, and it copies over to this guy's X, Y, width, and height, all right? So it copies it. Okay, now it finishes the copy. Then what does it do? So let's go back to the previous version. Right, so right here, here's our new, right? Here's our add, and it goes, boom, right into it. Here's the sub. Our sub goes into here, set. So right now, let's go back to this new, right? So we're following here, blue ghost, new rectangle. So there's one new. Now we go into the definition. It's passed, right? The pointer's passed. We go to the set. Pointer's passed, and boom, it's going to now set the pointer to that. You see how it's going to set the pointer to that? So this function here, the set, initially had a new, then we just replace it with this pointer. So what happened to this original one? So let's call this A. A was created with the constructor. Then we call set, then comes crossover here. Boom,
It's free.
So now this thing points to B, and A is not used anymore. So this is marked for release, right? Because it's a garbage collected system, right? But if I call set 15 times on this image, I just new and release things 15 times. So this seems a little bit heavy, right? So we got to follow and track the news. So what we do here is we don't pass in the news. So here's the blue ghost. We don't pass in the news. We pass in the data. Then we come across here. Here's the data. Then we marshal the data. Marshal is a fancy word for move. Move the data into here. Then it comes into this function. Cool. Now, here's our initial allocation. We just change the value. We don't release the memory. And that little move will make it twice as fast because we're not creating another new, and then have a thing out there to be garbage collected. Right. So that's the first thing kind of do. The second thing is we look back at this code and there we go. We were passing the pointers to the texture, right? The pointer to the texture. Well, as soon as we do the pointer to the texture, that means the texture has to return a pointer. Now we have to keep this pointer around and we have to pass it over to this guy, right? But we gave the texture a name. So technically we don't need the pointer anymore because we got a name. So if we pass a name to it, we can look up the name. So over here, we pass in the, oops, oh, I didn't do that yet. I will. Later, we'll make this, remove the pointer on this and this do it by name. So I got ahead of myself. All right, so now the question there is like, holy crap, I'm getting confused. What the hell is happening? So let's just look at this. If we take these two, and again, you need a good difference tool. I recommend AR Access Merge. That's the one I bought personally. It's like $29 or $20, but you can get the free ones. But we can look at here, image, and I just click on this and boom, there's all the changes I did. So I can see exactly what's happening. Here's my XYZ height and float. Here's my pointer. I can literally see what I did here, right? And then, okay, so image manager, what got changed there? Right here, XYZ, then here's past here, here's a sub. So I can track this stuff and see what's actually happening. So I'm trying to reduce the number of news and delete, right? So that was all the way up through last week. So now we get into new material. Any questions so far? Is this making sense? I know I go fast, but we have a lot to cover and we're slowly drifting slower and slower behind, which I don't mind, but it just means, you know, maybe I'll add some supplemental lectures or material to catch us up and keep us up. So, all right, any questions at this point? All right. So, so here we go. So we have all the I'll remove the news, right? So now what we're going to do is basically add a sprite node, right? And what is a sprite node? So here. Okay. I hate this new version gave me this stupid bar down there. And we're going to add sprite node and sprite node manager. Like, what the hell are those and why do we need a sprite node? All right. If you had a class, right? So we have a manager here. This is a simple manager, right? And we're going to manage effectively nodes, right? Right here. Right? So we have a manager that's going to manage these nodes. And because we know this whole list is homogeneous, right? We can actually just basically downcast and we know we can get to a sprite, Problem is, what if we have different sprites? Let's say we have this sprite, we have a sprite, we have one sprite, we have another sprite that is short, let's just say, 2 variables. This one has, 5 variables, and this one has, many more variables. Now, oops. Don't know why the color matters to me. So we can still put it in a linked list, right? But if we want to go down, this isn't for downcast. This is not allowed because we don't know what type it is. This might be sprite type A or sprite type B or sprite type C. And we don't know. All we know, we're on this linked list node and we're trying to downcast it. And this becomes problematic. So how do we downcast it, right? How do we do this? So the question we're really asking is, how do we have heterogeneous types in a single linked list, right? So how do you have, heterogeneous, types in a single list, right? And now you see a problem because like, well, hell, I can't do that because I can't downcast correctly, right? So when you get into trouble with inheritance, the solution almost always says, go to composition. So again, drill it home. A and B, this is aggregation. This is composition. Right. All right. So generally composition there. So what if we had this? What do we want to do? All right. So let's get back to the goal of this exercise. Sometimes you get so preoccupied with the alligators trying to bite you, you forgot why you're in the swamp, right? So what are we trying to do with this? Well, we have all these sprites. Cool. Sprite manager. Great. Excellent. Awesome. Right. But we have to call update on those sprites. Right. And those sprites might be different sizes, different shapes. So there'll be different updates, right? But then we also want to render all these. So what we're going to have is, whoa, I don't know what the hell that is. I don't even know what that window is. All right. What we want to do is we want to have everything in a list to draw them. We want to have everything in a list to update them, right? So we know right off the bat, we have, here's our D-link. But what we want is a class that's going to draw it. So abstract draw, abstract update, right? So we need the update and draw functions on this function, on this guy. And so let's go to Sprite. I click the new one. All right, Sprite. Yeah, it's right now. Okay, so here's my Sprite node. And what I'm gonna have in my Sprite node is it links to the D-link, right? So cool. We can even see the diagram in that pretty quickly. So here's this. It's going to show base. There's my D-link. Okay. Now, what we want in this is the ability to draw and well, before we do the draw, we want the ability to have multiple different items together. Oops, I can see that. All right. So what I suggest is, instead of us trying to, let's get out of this part right now. If I have different size things, what if I just had this, a pointer to a sprite base. And then from here, I have a 4 element, I have a 2 element, I have, you know, a really long one. And all of these types are like this. So what's happens now is that I can connect to my sprite base, and that sprite base can have different sizes of objects. And then if I want to, I just have to say, okay, well, this one has draw, and the draw function, go over here and calls this abstract draw. And now we can have overloaded draw here, overloaded draw here, and overloaded draw in this one. And so basically I can have a linked list of sprite node, and a sprite node just holds a pointer to a sprite. And now I can handle different sizes and different shapes, because I'm not going to be downcasting in this list here. I'm just going to be calling draw or update. So let's take a look at this code. All right, so here's my sprite. It's now going to point to a sprite. And so this is my normal sprite, you know, that we know and love or hate, right? And so all it does is, this is just a wrapper. So instead of driving from sprite, I'm going to do composition to it. Or sorry, aggregation. This will be aggregation to it. Reason why it's aggregation is, who owns this sprite? Sprite manager owns it. So here, sprite manager, you know, owns the base, which then points to the active. Where did the rest of my code go? It's over here. You guys went away. There you go. So there's my sprite manager, which then this guy here points to oh, sorry, this goes this way. There you go. Right, and then this has the drive class manager. Right, and then this guy points to the head D-link, right, and now this. See how complicated this stuff gets very quickly. So let's move this over here. Right, so your sprite manager actually owns the sprite, but our sprite node manager owns the Sprite nodes, right? And so this is where sometimes UML isn't as clear what the hell's going on here. So let me kind of give you the summary here. You have Sprite node manager. It should be a different color. Sprite node manager points to Sprite node, then connected off of this. Sprite, which then is connected to Sprite manager. So Sprite node manager owns the Sprite nodes. It points to a Sprite, and the Sprite is owned by the Sprite manager.
So I had a question.
Yes.
So why, like, I understand that it's from the man base, like the node, the Sprite node thing, but it almost looks like it doesn't belong there because like you have it connected to all this stuff. So like, why does it have to be there necessarily? Like, because how?
Which question? Why does what have to be where?
I'm sorry, because the man base, like the manager base, because you have that connected with the Sprite node base. That's what you were showing, right?
This picture or a different picture?
It was something in the other slide. Like it was the previous one.
This one?
I think it was the UML diagram, and you were saying you want to show it clear.
Yeah, I think this one. The problem is
I
the
think that's the
diagram's
thing.
right. The diagram's right. It's just it's a little mucky to understand what the hell's going on.
Yeah, because you have Sprite man and a man base.
But right, but you gotta think
Yeah.
about this. Remember, when you see Sprite Manager in your head, you got to say, well, that's not part of it. So you got to remove it off your head.
Right.
So you got to go, okay, these two, right? D-Link node here, right?
Yeah.
But this right here is an aggregation. The
Right,
Sprite is
right.
an aggregation. So the Sprite Manager actually only owns Sprite nodes.
It's just like you said, the UML, because it's like,
You mean the Sprite node manager only owns Sprite nodes?
I'm sorry, the Sprite node manager, right? Got the wrong one here. I deleted the wrong one. Yes, the Sprite.
yeah,
node,
there you go. There.
Yeah, yes, I'm
Okay.
sorry.
Now you make more sense. Okay,
The
because I was
Sprite
like,
node
why?
manager only owns the
All
Sprite
right.
nodes, but
Yeah,
then
because that's the
the Sprite manager owns the Sprite,
yeah, okay. Now okay. It was just
right?
because you
And
had the wrong
so,
thing on there.
um,
Yeah,
what I was trying to say, like here, is like the Sprite node manager owns the Sprite node, and the Sprite manager owns the Sprite,
right.
and the Sprite node just points to the Sprite.
Yeah, I
Like, you know,
understand.
this line right here just points to the Sprite. It doesn't own
Even
it.
though, I
No,
was just gonna,
it
even though,
doesn't. The problem is the whole concept of ownership isn't part of the language. It's a convention that we put on it.
yeah,
You know, And if get super technical, even public, private, and protected is a convention we put on it. The code, if you look at the actual disassembly code, it doesn't know it's private, doesn't know it's public, doesn't know it's protected. It's just a behavior we add on top of it. So so now here is kind of like the sprite node, the nodes right here, these are the nodes. So, this is a node, this is a node, this is a node. And then this is a sprite. I'm sorry. I drew this. Right. So these are sprites.
So we'll be adding some way to the sprite manager to return the different kinds of sprites that exist.
Maybe,
Okay.
because right now we don't need to know. We just say it,
Yeah.
as long as it does the contract draw, we're happy.
Oh, I mean to like create the different kinds of sprites.
Yeah, so we're going to pass a sprite node. We're going to pass a sprite to a sprite node.
Yeah.
Yeah, and that's just the link. So this is kind of the ownership where you can kind of see that there's this separation. The sprites are owned by sprite manager. Sprite nodes are owned by sprite node manager, and sprite nodes point to sprites.
Yeah,
Right.
no, I meant the sprite manager right now, it only returns one kind of sprite.
One
like
kind of
the-
sprite, right?
Because I was only thinking it's almost like, because you have a manager for like because the nodes holds the data, and then you have the sprites, the objects themselves. So it's like I was thinking you could almost combine them into one, because they're kind of always, isn't there always going to be a node?
No, you're going to get in trouble if you do that.
Yeah.
Just have faith right now for a little bit.
Yeah. So there's definitely a reason why, because you're going to be changed. Must be
We're
because
going to be changing the requirements. I know what the big picture is coming.
Yeah, I know.
Yeah.
Yeah, I was just wondering. Yeah, I got it.
All right, so we added the sprite node, right? And so the sprite node, sprite node basically just holds a pointer to the sprite. That's it, right? As dumb as it comes. And when we create the sprite node, we can set the sprite name. The sprite name can go back through and find it and associate it, right? So let's look at the code. And then we get into the stuff that I wanted to talk about today. It only took 2 hours to get to the stage. All right, sprite manager, blah, blah, blah. All right, sprite node, right? I'm not going to say add, because add seems wrong because we're not adding it or creating it. So I'm going to say attach. So I'm going to say attach all these sprites. And because I have names, I'll just attach them by name instead of pointers. Okay, so then the attach becomes really simple. We just sit there and say, here's the name. We pass it down there, so we do the whole, get the instance, add to the front, blah, 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 set. And when we're in the set function, this is where we're still a name. We need to convert it to a pointer. So we call the find. The find will find it and associate it. Okay. Always, whenever you think about it, try to add as many asserts as you can, because that will help you find your bug if you induce a bug. Right. So that's it. We did nothing other than just created that node display, right? So nothing's really happening.
So the nodes have a direct reference to the sprite manager. Okay.
No, not the sprite manager, to the sprite. So a node has a direct pointer to the sprite. Anybody on Earth in this function has access to the sprite manager because it's a singleton.
I see. Got it. Okay.
And that's why the singleton's nice. It's like, I need a singleton here. Boom. You can just call it. Otherwise, you have to pass that stupid pointer around, right? Does that make sense?
Yeah.
Okay. So, all right. So we did this, right? Now let's go to the sprite manager. So this is sprite node. Let's go to sprite manager. So the sprite manager, the sprite node manager has the classic kind of setup and destroy and all that stuff, right? So it has, you can see here in the corner, it has the create, the destroy, And then we have the attach, right? And we can still, dump it and print everything. But I added one function called draw. In draw, okay, what does draw do? Well, in my code, instead of me calling render, right? If it's on the draw list, on the sprite node, I just say sprite node dot draw. Thank you very much. And what this is going to do is grab the iterator, right? Iterate through this and call render.
And this just draws everything that's on the
The-
sprite node man active list. It
Yes,
doesn't,
yes.
there's no like, oh, this stuff has been updated, this stuff hasn't,
No,
etc.
no, it just draws everything on the active list.
Okay.
Point blank. It's up to somebody ahead of time to update it. And so this is going to call off the iterator, and the iterator here is going to give you the active.
Mhm.
Right. So now this, got a lot cleaner. So instead of from this, it goes boom, right? But now you have an interesting, oh, great. What did I fat finger? Oh, right. Oh, I moved that I somehow. All right. All right, so now, this draws everything is kind of same. But here's the catch. If this sprite node is what's being drawn. So if I sit there and say, you know what? Just attach one bird, only one bird will be drawn. Or, oh, the dump is giving me trouble here. Cool. Oh, fix that. There. Yeah, I clearly bugged. So only the white bird's being drawn, even though everybody's being updated. Everybody upstream is being, oops. Everybody's being updated because I only put one thing on that list. Only one thing is being drawn. If I want this and the red bird, and we'll say the pink ghost, boom. Not only those items are being drawn. So now this is interesting. This sprite node manager starts becoming our display manager. This is what we can draw in and see on the screen. So now what I want to do is kind of getting to the next concept here. What if I wanted to all right, if I want to sit there and draw the ghost, right? And then I want the bird. And as they're flying through, is this bird going to be on top of the ghost or behind the ghost? Well, it actually just depends on the order, which one gets drawn first. If I draw all the ghosts first, then when I draw my bird and, take my bird and move it around, it's going to be drawn on top of it. So then it'd be drawn on top of it, right? Blocking the guy. If I drew my bird first, then the aliens will be on top of them. Oops. I already screwed it up, but if I drew my bird first, then my ghost would be on top of the bird. So what we can tell is the draw order is actually important. Well, what's my draw order? My draw order is the order that they're attached, right? So let me go back here and draw.
Can it be reverse because you're pushing to the front?
Right. It's totally, this is reverse, but red bird. Let's see if I get to
So
it.
like red bird is drawn last, or red ghost is drawn last.
Oops, the wrong guy. Oh, maybe I'll do it that way. Red bird, and then red bird, red bird, red bird. Okay, red bird. I'll make him bigger. 150, 150, and then I'll put him at 300. All right, you can see the red bird's behind the guys right now. I didn't repeat it, so maybe it will repeat. So you see how he's behind?
Mhm.
Okay, so now and you can see it's behind, right? Well, then if I just change the ordering, now he's in front, right? Which makes sense. Problem here is when you have a couple hundred sprites, you're not going to remember attach it in this order and do this and change this order and all this other stuff. So I suggest we draw by buckets. So what if we had this? We had a bucket called birds and a bucket called ghost. And then in here, we have all the birds. We don't care what the order is, it's just all the birds together. Then in here, we have all the ghosts. And then the order that we draw, we start here, we draw all the birds first, then we draw all the ghosts second. If we just change the bucket order, saying, you know what? Let's just change. And all we're doing is just moving this top level node. Now all of a sudden all the ghosts get drawn first and then the birds, right? So this is called sprite batches, right? So when we're essentially having a collection of nodes that are in a collection. So a collection in a collection, right? And
This collection or batches, industry term or a term?
yeah, this was coined 30 years ago by XNA, which is the predecessor to Microsoft Xbox. Yeah.
What's the manager to the left? Is that?
That's be the sprite batch manager, and these
Okay.
red boxes be batches.
Yet another manager. Okay.
Oh yeah, and this is why now you're starting to see like, okay, now you get why we're not hard setting things and why we want to use and this is a sprite batch, right? And then this is a the problem here is to do this, we're going to have over here, we can't do this directly, so this becomes our sprites, and what we have here is our a different color. Node manager that holds all the sprites, you know, then
Is that the sprite node manager?
right, but we're gonna have to tweak it.
Okay.
So this is like a different node manager then. right? Or
No, we're gonna
this
rework
is
it.
the node base, or you're gonna rework it.
Work it,
Okay.
right? So this is what we're kind of doing. Conceptually, we're just having a collection, right? But when we look at our node manager, here's where it's right now. Our node manager looks like this. Node manager. Try us from manager. Let's a sprite. That's right. Because this is what we have. The problem is we want to take this whole picture %50 chance to get this right. First of all, I learned you have to delete that stupid thing. Okay. I keep thinking I'm in Visio where I can group things, right? So here, we want this, then we want sprite batch. Manager. That's what we want. So we want this. We want to basically have a linked list of managers. So we want this, but we want many of those into another thing. So we take this and like that. And this is essentially a sprite node, right? And the rest are there. The problem is that this is a singleton. That's the problem, that this guy right here is a singleton. Well, you can't have only one of these. We're going to need many of these, right? This is many. So we need a manager. So the first thing we need to do is unsingleton this guy. So we have to kind of unsingle it, make an instance. Otherwise, we can't drive from the sprite batch. I'm sorry, sprite batch should look like this. I screwed up one thing.
Yeah, I was actually thinking you were about to say manager of managers, but I actually didn't think that you were. So that's really interesting that you would really do that.
Do it like this, right? This way. And then this becomes there. So you have, I mean, just kind of see how crazy sauce we're at. We have just ignore, just focus on the right side, right? The right, I mean, sorry, left side. We just have Sprite batch manager that manages Sprite batches. Easy. We understand that. We get that, right? That makes kind of sense to us at this stage. And we can have many Sprite batches. We have 1, 2, 30, it doesn't matter, right? But the Sprite batch itself is a manager, right? Of Sprite nodes. The problem is this guy, oops. The problem is that guy is a singleton currently. It can't be an instance, so we're gonna have to rework it and create a singleton for that. All right, so we're gonna take the Sprite node and make it remove the singletonness of it. Sorry about the coughing. I have a really unique blood disease, and that's coughing means I'm actually out of oxygen. I finally figured out. I'll be back in 1 second. Sorry about that. I took a handful of horse pills and I didn't have water to swallow, so it stuck in my throat. All right, so what we had before was the Sprite node manager was a singleton. You say create. Then from there, we say attach. And then we say draw. Now, should we rework it back to an instance? So now it becomes an allocation is the manager. And then the pointer goes dot attach. So it looks the same and behaves the same, but it's not a singleton. This is a worthy step to do. Now, to see what we actually did. We look at these two. Sprite node. So here's Sprite node, and I just comment out the print, the Sprite node manager. And basically what I did is I took out the create, the destroy, and all the word statics here. And I now, instead of doing the whole idea to get the instance, I just say this dot base remove, so I basically put it back as pointers. And this is why the difference tool is useful. You can kind of see exactly what's going on there. So basically I de-singleton it, right? All right, so now we can do a sprite batch. So a sprite batch now
Perforce doesn't have like a file difference.
it has a file difference.
Oh, to do it by just a single file at a time, not like
Yeah.
all of the different. Oh, okay.
Robin somehow uses it. I don't know how to use it. I just have an external tool, but you need a difference tool if you're going to survive this class. So you can get a free one, you can get a trial one, you can fork out $20 once and use it for the next 3 years.
Are we allowed to post this on GitHub in a private repo? That way we can use GitHub's differencing tool.
I really don't want this stuff growing lakes because what happens is GitHub, it gets mined, even private.
Okay.
So get your own tool. It's going to be useful. You know, you can get beyond compare. There's a whole series of free ones. All right. So where am I at here?
We were doing the sprite batch and it was
Sprite batch,
like,
right, yeah.
loading, and
Slowing
for
down.
some reason it wasn't showing or something.
Yeah, okay. Yeah, thanks. All right, so sprite batch. So here we are. Sprite batch. Right, sprite batch. All right, so sprite batch. What does a sprite batch have? Sprite batch has a name and a pointer to that sprite node manager that we just de-singletized, right? That's it. So now if you look in the diagram, sprite batch should look awesome. Sprite batch manager manages sprite batches, and sprite batches point to sprite node. There. All right, so it's kind of like we think sprite batch manages sprite batches. Sprite batch manager manages sprite batches. Sprite batch points to a sprite node manager. Okay. So now what does that give us? Now we can create a sprite batch manager singleton. Then we sit there and say, okay, we'll create a sprite batch. We'll call it birds. Angry Birds, and we'll call one Pac-Man. So there's our 2 buckets. We say Pac-Man, attach, 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 birds, attach, 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 right? We just say draw. So you can see the birds are in front of the Space Invader, the aliens now, right? I mean, the ghosts, sorry. The birds are in front of the ghosts. But then if we just change the order of the buckets by creating them in a different order, now they're behind. So all I did is move those 2 buckets from back and forth. So here, I just swapped the order of these 2 buckets. And so what you're going to do for the sprint is you're going to do a sprite batch manager, but instead of doing, depending on orders, you're just going to give it a priority number, and it'll be inserted in the order that you set by the priority. So if you sit there and say, ghosts are in priority 3 and birds are in priority 10, well, ghosts will be first and then birds will be 10 after that. But if you say birds is 1, it's in front of ghosts. So you can now have many buckets, and you just set the priority and it will kind of set what order the buckets are in. So you're not dependent on even the order you insert it into the list. Does that make sense?
Yep.
All right, so now keep on going. All right, so so you're going to do the same thing now, and we want to have box sprites. And box sprites are different than normal sprites because they draw a box, of course. So it's slightly different data, but you don't have to do the whole abstract concept thing again. And so you're going to add a a box sprite which has line color and points to a box thing. And you have the respective manager with that. And box manager. So here's the sprite box manager. So sprite box points to manages sprite boxes, right? So same thing as seen before. And now this is the boxes right here. You can change the color of it. You can change the, and it behaves like a sprite, right? So now we get into a problem here is we want our sprite batch manager to handle both sprite boxes and sprites. So we will rework it and add a contract to this. So the arm waving I just went through is, creating a whole sprite box, which I think you guys can understand how to do that. All right, so I'll load a couple of these.
So both your sprite box and your sprite would then inherit from sprite base, which has the contract of the draw and update on it.
You got it. You're seeing the pattern. So sprite base, this has the contract of render and update, right? So now, and then your sprite node points to a sprite base. So it's a real small change, but it's pretty profound. So what you have is this. How do I render a sprite? And then how do I render a sprite box? Right? What I do is I do the classic thing where I have a base class and I just have an abstract render and an abstract update. And now each of these things get overloaded, overload and render or draw, I forgot what I called it. And
Render in the code,
yeah,
at least that version.
yeah. And then then overload and render and overload update. Right. So if you talk to this level and you say update, remember, you're going to only be A or B. So if you're all of this, it will call the update. Or if you are a sprite, you'll call the sprites update. So now our sprite node, oops, crap. So there you go. So a sprite batch manager manages sprite batches. A sprite batch actually points to, sorry. No, actually it owns that. No, it points to a sprite. Yeah, it points to, it owns, let me get this right. No, it points to a sprite base. And sprite base is either has a derived class of a sprite or sprite box.
And what about the sprite nodes?
Excuse me?
What about the sprite node?
Sprite node. This is this. I'm sorry. This. I forgot a whole layer here. Oh hell. And then. Could I? So. There you go. Yeah. So Sprite batch manager manages many Sprite batches. Sprite batch, a single Sprite batch has many Sprite nodes. Each Sprite node points to one Sprite base. Sprite base has the abstract method update and draw, and it's overloaded in the derived classes of Sprite and Sprite box. All right, so here we go. Sprite base. It has the render and update. And so now our sprite derives from sprite base, or sprite box derives from sprite base. So our sprite batch, see how well this goes. Yeah, it gets a little hairy. So so here's the, no, I don't have it well laid out there. Right, so we have a sprite batch manage. Let's take it from sprite batch node manager node out. So the node points to the base. The base has both the sprite and the sprite box, and the base has the contract of render and update. Then sprite batch points to the sprite node manager, which then ... controls the sprite node manager. Then a sprite node batch, control sprite batches, which then controls sprite node managers, which ... controls sprite nodes, which then has a pointer to the base, which has different sprites. So what does this buy us? This buys us the ability to have in our buckets different size and different shape sprites. We're gonna have sprite box, we're gonna have sprite, a normal game sprite. You can also eventually have collision sprites. We have a lot of different things in there. And so now in the game, how does this look? We just have the sprite batch manager, the sprite manager, the Sprite box manager, you know, all these things, right? So we create these. And here we create the managers, a box, a bird, and this. We do the appropriate attachments, but these boxes dictate the order. And then we can call Sprite batch manager, boom, draw. You can see the birds are in front of the box. And then we can, no clue why I just clicked. And we can change the boxes to be drawn on top of everybody else. So you can see that the box is on top of the birds. You know, so we can kind of start controlling stuff, but basically this technique of having a common base class and then you don't care what's underneath allows you to have different size or different shape classes underneath. So it doesn't have to be homogeneous, it can be heterogeneous. And you do the contract by sending in the abstract method in your base, and that forces you to overload it in your dry class. Okay. So next thing is we're going to add a priority queue. Does everybody know what a priority queue is?
Yeah.
I know what a queue is, but I've never heard of a priority one. I mean, I would just think it's like a queue, but
okay,
they're
so
different.
A priority queue is it's basically a queue with an insertion order. So you place your nodes in here, but your nodes, so let's say this node is 10, right? And say smaller numbers are here, and then larger numbers are at the end of the list. And so now I have this new node, right? I say insert it, and its number is 50. Like, oh, okay, let's go ahead. All right, so this is 50, right? So what you do is you say, oh, 50. Does it go in front? No, it goes after. Okay, cool. Then you're like going, all right, here's another node, 75. You're like, okay. Does it go here? No, 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 drop it there. And you're like, here's a node, 62. No, 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 in between. Here's a node, 51. You're like, oh, it's going between there. So
are we going to implement like a heap data structures here?
no, this is just, you're just inserting it. You're just inserting it into a linked list in order, in a certain order.
Oh, okay.
Yeah.
That's all it is.
That's
Or-
all it is.
Oh, okay.
Okay,
So it's
fancy word. That's all it is. But here's the thing. Never in a million years do you call sort.
Yeah.
Because you're going to insert it in sorted order, right? So that's the whole key. Inserted in sorted order. Right? So you're going to insert in sorted order. Once it's there, you never do anything else with it. All right. When you're going to eat things, sometimes you're going to take things off a list. You're taking them off the front of the list every single time. So, consume from the front. That's essentially a priority queue. The difference with a queue versus a priority queue is you keep pushing everything always to the front and you pop things off the front. Here, you're going to place it into to basically rank order based off of some key. Okay, so why do we have this, right? We want to do animated textures, right? Animated textures. So that's the whole key, is we want the thing to animate. So let me show you what it's going to look like.
So just a question. If you need, for whatever reason, change that data that you had in the queue there,
you can pull it off and put it back on.
yeah, you need to pull it off and alter it and reinsert. Okay.
So this is one sprite. And what I do here is I just change the image every so many frames, right? But I don't do the frame. I want to keep everything dumb, keep everything super dumb. So I'm going to create a timer. And this timer is going to use this concept called command pattern. Command pattern is super simple. It's one of the, I think, one of the most nicest patterns that are around. I use it all the time. It's like my go-to hammer. And basically what it is again, you just have a base class with a contract. The contract is called execute, right? Then that means your drive class has to implement execute. And so you call execute, it goes, okay, and then the concrete class calls it and it does something to somebody else. That's it. And sometimes I'm trying to think, what was it called before in C#? There's sometimes they have something like this built in language that's so damn useful. This is the OO way to do it. You can do this no matter what language you're in. God, I can't think what it's called. Oh, it hit me at some point. Is anybody really good at C#? Yeah.
I am, but I'm not sure what you're getting at.
What's the language is?
I mean, we're taking this class.
No. I'm talking about like professional C# developer. I will figure out what it's called. There's a name for it, but this is built into some languages, and C# has it built in. But we're going to do the OO way.
Sounds like events.
It's kind of like an event. There's another one that's it's a small variant.
Listener.
What?
Listener, invoker.
No.
Delegate.
What?
Delegate's another one.
Don't worry. It doesn't matter. I should have never opened my mouth. I want to retract that. All right. All right. So here's the command pattern. Basically, you just have an execute as the base contract, and then the drive contract, you do your action. And the catch is you're going to do your action onto somebody else, right? So that's what it basically is. And what's nice about this is that this is an object, right? So when you instantiate the concrete command, it's an object, which means you can copy it, you can pass it around, you can hand it to somebody else, you can manage these things, right? So you have this whole concept of an encapsulated request, right? That we can move around and copy. So here it is, we have the base class execute, the concrete class will actually implement the execute, and it will do some action onto a receiver class. That's it. It's just that simple. It's pretty kick-ass, right? All right, so why is this cool? So the rest of the stuff you can crock through. The reason why this is cool is we're going to have a timer. And the timer is going to have basically commands here. So it's going to have an overloaded exe function, right? And there's many of these. And what we're going to put in here is going to put a time. So the singleton here says, I hold my current time. and let's just say it's 0, right? And you're going to call occasionally update. And it goes, okay, get the current time. So the current time now is 1. Is anybody on this command list equal to 1 or younger than 1? So this time might be 5, this might be 10, this might be 11, right? It goes, no, do nothing. Call update again, gets updates current time is 2. Is anybody there? No. 3, no. 4, no. 5. Oh, first guy here. Jump to the first one. If its time is equal to or less than the current time, execute. We execute it, then we take it off. Oops, take it off the list. Then our time keeps moving forward. 6, 7, 8, 9, 10. Oh, here it is. Here's the first one. Execute it, take it off the list. So why are they sorted? Wait, not sorted. Why are they inserted in sorted order? Imagine
That your least amount of time is always first, and you don't have to
exactly.
search the whole thing every time.
Exactly. So the worst scenario is you have literally thousands of these, right? You don't want to go check the whole list to see who do I trigger, because they're always inserted order. You start going, I eat this one, stop. I don't care about the next 100,000 of these, because you did the dirty work when you inserted in order. That's it. The second cool thing about a timer with priority queue, your command can do anything. So your command can do anything. So it can sit there and say in the exe, it can do all kinds of things, and they can say, you know what, add to timer again. So you can have it do a lot of different things, and the last one be add the timer. So it can trigger itself, fire off all this stuff. So boom, boom, boom. Then it comes to this line and goes, oh, add itself again. And it inserts it right back there. And then when this thing executes again, it can do those commands, and it can add itself back. And what you have is you have a command that can replicate itself, or it can insert itself back onto a list. So I know I'm going to run out of time, so I'll set this up. Go back to this one here. Yeah, so this thing is going on click, 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 click. And what I'm doing with this, and I'm running out of time, but I'll let you guys start digging through this, is my timer is a manager. What I have on my timer, I'm managing timed events. So my timer manager, or time event manager, manages time events, right? And my time events are queues. And what I have in my time event is trigger time, delta time, right? And so I can basically repeat. So I can have a command that says, print this screen and then add itself back to the timer. So this thing will go forever more. So it keeps adding it. You do one and turns around, put another one back on your list. And so this allows us to keep changing the images. So we'll get into this. But I was hoping we were going to get through this. This is where I want to be. So we're just now a little bit behind. We'll get into this next week. So just kind of give you a preview on the timer stuff. So I won't put that in the sprint. I'll put the timer in the next sprint. All right, so questions? No questions. Cool.
I have a question, but it's I'm gonna save it for after hours,
Okay. Okay.
office hours.
All right. So what you're going to get is the next sprint. The next sprint is going to basically be create a Sprite batch manager, create the Sprite box managers, make sure you have everything in manager, everything needs to be singleton, and you want to be able to move your Sprite batches back and forth. Your Sprite batches will also add priority. And suddenly your project in the last 2 weeks is growing really quickly. And what you'll see in this class, which is really weird, we're making systems and infrastructure for like 6-7 weeks. So at first week, the first 2 weeks is kind of like nothing's going on. Then all of a sudden we start doing something. Now we added managers and we added batch. And then the thing is like going, I mean, it just takes off. And then you're at here and you have all your systems and you just start cranking and you can finish the rest of the project. So you can see that it's really important to stay on top of this. This material is going to go really quickly here because all we're doing is adding another concept, shake and bake, add another concept, shake and bake, add another concept. So at this point right now, we're doing pretty good. We have a lot of patterns and I'll shoot off a summary of the patterns we're doing. But what we have essentially now is the priority queue, the command pattern, the factory, the adapter pattern, and the template, the iterators, object pulling, and singleton. So we're starting to get a larger and larger collection of this stuff. So, it's starting to come together and we're starting to use this stuff. And hopefully, please ask questions and more of the why is this working or why should I do it this way or whatever, because you need to start kind of buying into the philosophy or the belief here that this is, one of the weirdest things here is at the end of this week's lecture, right? We're at 80 files already, right? And if you're minus 80 files, minus the resource files, there's 3, and then the diagrams. Oops. $10. So 80 minus, say, 15, we're about 65 classes we made already to get to this stage. That's pretty cool. And it's in every week you're going to be adding 20 more classes. Our classes are really small. I mean, they seem all intensive, but they're actually quite small. So we have a lot of little classes. When we start doing the timer, you'll see classes like, it's probably easier to show you. The execute. Look at this. This is the whole execute. The command class. There's the command class, right? These are small, so we're starting to create a lot of little bricks and stamp them together, right? There's another one that's, again, if it's within one page, it's really small. We have some that are a little bit bigger, but they're not that much bigger because if you really think about it, there's a couple access, there's a couple comparisons for the manager, but this is all the data it's holding, so it's holding a little bit of data. Then you have like the Sprite base, and that's essentially all it's holding is a name and a pointer to the Sprite node manager. So things are being reused a lot, and that's where we're getting the complexity. So keep on going. So what I'm going to do is on I think Thursday, I noticed that some people just need a little bit more, you're not used to coding. I don't know, maybe I'm misunderstanding this. I was offering to do like an open office hour on Thursday where I just code and you guys can watch it or ask questions. And you know, I don't want to go into anybody's problem, like go super deep into one person's problem. Say, you know, say Jim's or Lisa's really deep. Lee, I want to show you. I'm having trouble with this idea. I want to show you how to kind of code this idea or get comfortable with this. But at this stage in your career as a student, you should be comfortable starting to write a lot of code with descriptions, not with, hey, this is what I need to do. It's, you know, like, tell me line by line and what functions. It's like, here's the problem, start to code it. You have to start applying the problem solving and the descriptors in English, and what does that translate into code? And the best way to kind of communicate this stuff quickly is with diagrams. And so when we do these diagrams, of course, now I'm not going to find a diagram. The diagram should be very, this right here has a lot of code going on in my head, right? When I see this stuff, you know, so I'm looking at stuff and like going, yeah, I summarized a lot of stuff in these boxes, but these boxes are actually much more expanded. You know, so that's one of the things to kind of keep in mind is that, you know, when we talk about the high level architecture and design, which means you might have to create 3, 4, or 5 classes just to make that little bit work. Also, I don't think I said this yet in this class, but you'll hear this a lot in my other courses and as well as this. Do not get emotionally attached to your code. You're going to write something and you're going to spend literally 3 days on it. At the end of 3 days, you're like going, shit, it's wrong. Or you're going to sit there and like, yes, I polished this. This is really good. And 2 weeks from now, you're going to realize your whole architecture sucks and you have to redo it again. That's how you learn. In software development, I really think you learn just as much from a wrong direction as you do from a right direction. So don't look at it as wasted time. Don't get emotional about your code. Your code is there to be thrown away and deleted. Then if you kind of have that attitude, you just write code a lot and you're like, oh shit, that was wrong. Okay, now I know what to do. You just delete it and you know you're not emotionally attached. But until you get to the phase where you can write code quickly and you know the code as you're writing it is working correctly, you're going to struggle with your debugging and making sure it's coding and doing what you want to do. So because of that struggle, you become emotionally attached. So just try and give you some advice. On average, successful students who finish this project throw away their code 5 to 7 times. So every line of code they keep at the end, it was probably thrown away 5 to 7 times. So welcome. Water's nice. Cool. Kill your babies undergrad. I like that idea. That's good. All right. No, not signal. I can't think what it is. I'll figure out what the phrase is just because it was kind of
There is an iCommand interface that basically has the stuff, but it's not like it's got any functionality baked in.
no, it was something more heinous with casting. And I was teaching it that way at first, and then I'm like going, you know what? I think I'm losing people, so I switched over to this. Now I can't remember what it's called, so I'll trip across it.
It's not reflection, is it?
What?
Reflection.
No. If you want to see reflection, I'm doing that in the unit test.
Yeah.
But you shouldn't use reflection. Reflection equals slow. All right. All right. I'll let you guys go. I'll go start office hours. Okay. Thanks, everybody.
Thanks.
Thank you.
Thanks, everyone.